Let's get right into it. You probably have at least one mirror in your house. You look into it every day. You trust it. It's a simple, reliable tool that shows you exactly what's there. A perfect one-to-one reflection of reality. Except it isn't, not even close. That flat piece of glass is actively lying to you. It's a funhouse of subtle distortions, bizarre physics, and psychological trapdoors. It doesn't just show you your reflection, it shows you an impossible version of yourself, living in a phantom room that doesn't exist, all while hiding its true color. We're not talking about Bloody Mary or ghosts in the glass. We're talking about the cold, hard, and frankly unsettling science that's hiding in plain sight every time you check to see if you have food in your teeth. So let's shatter the illusion. Here are the unsettling physics hiding inside your mirror. All right, let's start with the question that has probably bothered you in the shower at 2 a.m. Why does a mirror flip you left to right but not top to bottom? If you raise your right hand, your reflection raises its left. But if you stand on your head, your reflection doesn't kindly stand on its feet. What gives? The answer is that the question itself is the problem. Mirrors don't flip left and right. I know. That sounds insane, but stick with me. They don't flip you horizontally any more than they flip you vertically. They flip you front to back. Imagine you're walking towards a mirror. Your reflection is walking towards you. The tip of your nose is 1 foot from the glass. The tip of your reflection's nose is also 1 foot from the glass, but on the other side. Now imagine your back is 5 feet from the glass. Your reflection's back is also 5 feet from the glass. The mirror has taken you and perfectly inverted you through the z-axis. It has created a version of you that is inside out relative to the real world. Here's a better way to think about it. Hold up a piece of clear plastic with your name written on it. You can read it perfectly. Now walk around to the other side of the plastic. The text is now backwards. Did the plastic sheet flip it left to right? No, it's still the same text. You changed your perspective. You are now looking at it from the back. That's all a mirror does. It shows you the back of the world in front of it. When you raise your right hand, the one on the east side of your body, your reflection raises its hand on the east side of its body. The confusion only comes in because we try to mentally shake hands with our reflection. We imagine rotating our body 180 degrees to face the same direction as them, and when we do that, our right hand is now where their left hand was. So the mirror isn't betraying the laws of physics. It's betraying our very human, very flawed perception of left and right. It doesn't see a left or a right. It only sees stuff that is here and stuff that is there. It's a flip so profound we can't even describe it properly, and that's just the beginning. So we've established the mirror is performing a weird front-to-back flip. But where exactly is that flipped version of you? If you touch the mirror, you feel cold, hard glass. Your reflection's finger touches your finger from the other side. So the image is on the surface, right? Wrong. That person staring back at you isn't on the surface of the mirror at all. They're a ghost, a phantom living inside a room that doesn't exist. This isn't poetry, it's physics. The technical term is a virtual image. What you're seeing is a trick, a beautiful, perfect trick played on your brain by the speed of light. Here's how it works. Light from a lamp or the sun bounces off your face in all directions. Some of those light rays travel towards the mirror, hit the silvered surface, and bounce off at a perfect angle, heading straight into your eyeballs. But your brain is, for all its magnificent power, a little bit lazy. It has one core assumption it never questions. Light always travels in a straight line. It doesn't know that the light rays just performed a ricochet maneuver. So when those rays hit your retina, your brain traces them backward in a straight line, completely ignoring the bounce. It calculates where the light would have come from if it hadn't hit a mirror. And where is that? It's exactly as far behind the mirror as you are standing in front of it. Your brain literally constructs a fake, simulated room behind the glass and places a phantom version of you inside it. Every time you look in the mirror, you are seeing a perfect, high-resolution illusion of a space that is physically impossible. That bathroom behind the mirror, it doesn't exist. Your reflection, it's a projection, a ghost of light painted into a simulation by your own visual cortex. The mirror is just the catalyst for a lie your own mind tells you. All right, what color's a mirror? It's a trick question, right? A mirror doesn't have a color, it's mirror colored. It's the color of whatever it's reflecting. A perfect mirror would be pure white, reflecting all wavelengths of light equally. But the mirror in your bathroom isn't perfect. And it does have a color. It's green. I know, it doesn't look green. When you look at your reflection, your shirt isn't suddenly a different shade. This is because the effect is incredibly subtle. The glass that sits on top of the reflective silver or aluminum layer isn't 100% perfectly transparent. No glass is. It's made of a silica base, which has a molecular structure that happens to be just a tiny, tiny bit better at reflecting light in the 510 nanometer range, the green part of the spectrum. In a single reflection, the effect is so minimal that your brain just papers over it. It's statistical noise. But how do we prove it? Well, you can create what physicists call a mirror tunnel, or what everyone else calls that cool infinity thing. Find two mirrors and face them toward each other. Now look over the edge of one into the other. You'll see a reflection of a reflection of a reflection, stretching off into infinity. But look closely. As the reflections get deeper and deeper into the tunnel, the image gets progressively darker. That makes sense since no mirror is 100% reflective, but it also gets progressively greener. Each time the light bounces from one mirror to the other, that tiny green bias gets amplified. The first reflection is normal. The fifth is maybe a little bit tinted. By the 50th reflection, you're staring into a murky emerald-hued abyss. You are seeing the true color of the mirror, multiplied over and over until it's impossible to ignore. Every mirror is a portal, and that portal leads to a green dimension. Let's do a little experiment. Don't actually do it, just imagine it. Go into a room tonight, turn off all the lights except for one very dim lamp or a single candle. Now stand in front of a mirror and stare directly into your own eyes. Don't flinch, don't look away, just hold that gaze for a minute or two. If you do this long enough, something unsettling will begin to happen. The features of your own face, the face you've known your entire life, will start to change. Your cheeks might seem to melt. Your forehead might distort. Your mouth might warp into a strange grin or a grimace. After a while, you might not even recognize the person staring back at you. It could be a stranger, or it could be something that looks profoundly, monstrously not human. So did you just open a doorway to the netherworld? Is your house built on an ancient burial ground? Nope. You've just exploited a fascinating and terrifying glitch in your own brain. It's a phenomenon called the strange face in the mirror illusion. This is a specific, amplified version of a broader neurological effect called Troxler's fading. Your brain is an efficiency machine. It's hardwired to pay attention to new information and moving things, because back on the savannah, that's what kept you from being eaten. Steady, unchanging information, your brain gets bored. If you stare at a fixed point, the neurons processing your peripheral vision essentially say, all right, same old, and they just stop firing as much. The unchanging image slowly fades from your conscious perception. When you stare into your own eyes in a dimly lit room, you are locking your focus. The rest of your face, your nose, mouth, cheeks, is in your periphery. Because of Troxler's fading, the data for those features starts to get weak, like a bad cell signal. But your brain hates a vacuum. It demands a complete picture. So when it stops getting reliable data for what your face looks like, its pattern recognition software goes into overdrive and starts filling in the blanks. And what does it fill them with? Random fragments from your memory, primal archetypes, shadows, and anxieties. It's literally creating a monster because monster is a better explanation for the distorted data than nothing. The thing in the mirror is a corrupted file rendered by your own panicked operating system. We've talked about how mirrors flip you front to back, but let's go deeper. The person you see in the mirror is not just an inverted copy. They are a geometrically impossible version of you. They are, in a word, wrong. This brings us to a wonderful concept from chemistry and physics called chirality, which basically means handedness. The easiest way to understand this is to look at your own hands. They are perfect mirror images of each other, but they are not the same. You can't lay your left hand perfectly on top of your right hand. Your thumbs will always be pointing in opposite directions. No amount of twisting or turning in 3D space can make a left glove fit a right hand. They are non-superimposable mirror images. This is chirality. This isn't just a fun fact about gloves. It's a fundamental rule of the universe. Molecules have chirality. The amino acids that build the proteins in your body are, with very few exceptions, left-handed. The sugars you digest are right-handed. If you tried to eat the mirror image version of a sugar molecule, it would pass right through you. Your body wouldn't have the tools to process it. Now, look back at the mirror. The person staring back at you is made of light, not matter, but they are a perfect chiral flip of you. If you could pull that person out of the mirror and bring them into our world, they would be a biological catastrophe. Their heart would be on the right side of their chest. Their amino acids would all be right-handed. Their DNA would coil in the opposite direction. They would be an alien in their own body, unable to interact with our world on a molecular level. So that reflection you see every day isn't just you. It's your evil twin from the mirror dimension. It's a version of you that could never survive here. A perfect geometric echo that violates the fundamental biological blueprint of life on Earth. The person in the mirror isn't just an illusion. They are an impossibility. Here's a fun thought that will ruin the concept of now for you forever. You have never, not once in your entire life, seen yourself as you currently are. Every single glance in the mirror is a look into the past. Your reflection is a time traveler. A very, very lazy one, but a time traveler nonetheless. This is because light, for all its legendary speed, is not instantaneous. It travels at a blistering but finite 300,000 kilometers per second. In the tiny space of your bathroom, that seems like a non-issue. But physics doesn't care about what seems like an issue. Let's break down the journey. A photon leaves your ceiling light, travels down and bounces off your forehead. Let's say you're standing 1 meter from your mirror. That photon now has to travel 1 meter to the mirror's surface. It then bounces off the silver backing and travels 1 meter back to your eyeball. That's a 2-meter round trip. Even at the speed of light, that journey takes time. Specifically, it takes about 6.7 nanoseconds. So when you look in the mirror, you are seeing yourself as you were 6.7 billionths of a second ago. It's an imperceptible delay, but it is real. You are seeing an echo, a ghost of your very recent past. But let's scale it up to really feel the absurdity. Imagine we put a giant, perfect mirror on the surface of the moon, about 384,000 kilometers away. Now you look at it through a telescope. Light takes about 1.3 seconds to travel from the Earth to the moon. It then takes another 1.3 seconds to bounce back. If you waved at your lunar reflection, you wouldn't see the wave happen until 2.6 seconds later. You'd be having a conversation with a version of yourself that is almost 3 seconds in the past. Let's go further. What if we put a mirror on Proxima Centauri, the nearest star system, 4.2 light years away? The image you'd see would be 8.4 years old. You could look through the telescope and see a younger you, completely unaware of what the last 8.4 years of your life would bring. Every mirror is a time machine. Most just have a very, very limited range. Every copy of a copy gets worse. You know this instinctively. If you photocopy a document, then photocopy the copy and so on, by the 20th generation, the text is a blurry, illegible mess. Your mirror is doing the exact same thing to reality. Every reflection is a degraded copy. We already talked about how mirrors aren't perfectly reflective, which is why the infinity tunnel gets darker. A good household mirror only reflects about 95% of the light that hits it. Percent is just lost, absorbed by the glass and metal, turned into a useless little bit of heat. But it's not just brightness that gets lost in the process. It's information. The surface of a mirror isn't perfectly flat. On a microscopic level, it's a landscape of tiny pits and bumps. The glass itself has minuscule impurities. Each of these imperfections scatters and distorts the light in a tiny, insignificant way. In a single reflection, you'd never notice. But just like the green tint, this loss of detail is cumulative. Look back into that infinity tunnel. The deeper you go, the fuzzier the reflections get. The sharp edges of your face begin to blur. The image becomes less a reflection and more of a suggestion. You are witnessing information entropy in real time. Each bounce is like a generation of a photocopy, shedding data, losing resolution, until all that's left is a vague greenish smear. The idea of a mirror showing you infinity is a romantic lie. What it actually shows you is the slow, inevitable decay of information until reality dissolves into nothingness. It's a finite series of increasingly corrupted files, a visual demonstration that nothing, not even light itself, can be copied forever without loss. You've seen them at a carnival or a science museum. Funhouse mirrors. You stand in front of one and suddenly you're 10 feet tall and rail thin. You move to the next and you're short, wide, and your head is the size of a watermelon. It's a cheap, silly trick, but it's also a perfect demonstration of one of the most mind-bending and important principles in all of physics, Einstein's general relativity. The trick is simple geometry. A mirror that curves outward, convex, spreads light rays apart, making your reflection look smaller and distorted. A mirror that curves inward, concave, focuses light rays, which can magnify you or flip you upside down. You're just seeing the result of light bouncing off a non-flat surface. Here's the wild part. This is almost exactly how gravity works. According to Einstein, gravity is not a force that pulls things. Instead, massive objects like planets, stars, and especially black holes literally bend and warp the fabric of space-time around them. And light, which always wants to travel in a straight line, has no choice but to follow those curves. Astronomers see this all the time. A massive galaxy cluster can act as a gravitational lens, bending the light from a galaxy behind it. From our perspective on Earth, we might see the distant galaxy magnified, stretched into a long arc, or even appear as multiple separate images, just like a cosmic funhouse mirror. The famous spaghettification that happens near a black hole, where you'd be stretched into a long, thin noodle, is just an extreme version of the distortion you see in a tall, skinny funhouse mirror. So that ridiculous piece of wavy glass at the State Fair is a direct, tangible analogy for how a black hole manipulates light and warps the universe. It's a low-stakes glimpse into the fundamental structure of reality. The mirror isn't just bending your reflection, it's showing you how the universe itself can bend. So there you have it. The trusted, simple object on your wall is a green, time-traveling, information-deleting portal to an impossible, front-to-back flipped dimension that demonstrates the fundamental laws of space-time. Maybe it's not haunted by ghosts, but it is haunted by physics. And honestly, that's way weirder. If you want to find out what other shenanigans your reality is up to, make sure you're subscribed for the next video.